Welcome to GenAI Research Insight Hub channel. Let deep dive. The landscape of agentic reinforcement learning for LLMs, a survey. Why this matters. Imagine a smart robot friend who doesn't just answer one question and stop, but can look around, plan steps, use tools, remember what happened, learn from mistakes, and keep going until your real task is done, like researching a topic, fixing code, or booking travel. That upgrade from one-shot answerer to do-things helper is what this survey calls agentic reinforcement learning, Agentic RL. It treats large language models, LLMs, not as parrots that talk once, but as agents that make many decisions over time to reach a goal. Paradigm shift from LLM RL to Agentic RL. 1. State and observability. There's essentially one state, the prompt. The episode ends right after one reply. Think single question, single answer. Agentic RL, the world changes over time. There's a hidden true state SEC, and the agent only sees OA equals O before acting. Think many steps in a changing world. 2. Action space. The action is just text, producer response. Actions are text plus structured operations, example tool calls, clicks, code runs. 3. Transitions. PBRFT, deterministic one-shot to the terminal state. No real next state to explore. Agentic RL, dynamic transitions. The world updates. Structured actions can fetch new info or change external state. 4. Rewards. 1 scalar score for the final response from a verifier or preference model. No step-by-step feedback. Agentic RL can use task-level and or step-level rewards. Dense, sparse, or learned, example unit tests passing. 5. Objective. PB, maximize the single turn expected reward. Agentic RL, maximize discounted returns over a trajectory, which enables exploration and long-term credit assignment. The agent's superpowers, capability perspective. The survey organizes Agentic RL by what the agent learns to do: planning, tool use, memory, self-improvement, reasoning, perception, and a few others. Think of these like the agent's superpower cards. Planning, breaking a goal into steps and choosing good paths. Early systems prompted LLMs to pretend plan, but RL lets the agent improve its plans from experience, either by using RL to guide a search process, like MCTS, or by directly training the model's internal planning policy. Tool use, calling a browser, code interpreter, calculator, editor, and more at the right time. RL helps the agent learn when to use which tool and how to chain them for progress, instead of relying on fixed heuristics. Memory, keeping useful facts short-term and long-term. With RL, the agent learns what to store and what to retrieve for better decisions, not just dump everything. Self-improvement, reflection, noticing mistakes and adjusting strategy. What went wrong? What will I try next time? RL turns reflection from a scripted trick into a trainable habit. Reasoning, multi-step thinking, like chain of thought, but grounded by feedback from the environment, not only prompts. RL nudges the model toward useful reasoning paths that actually reach goals. Perception, understanding text, images, maybe audio or the GUI screen, so the agent perceives the world it's acting in. The survey treats it as a core module the agent can improve with RL. The jobs agents can do task perspective. The survey then flips the view. Instead of skills, it looks at task families where Agentic RL shows up: search research, code, math, GUI navigation, vision, embodied robots, and multi-agent teamwork. Think different levels in the adventure game. Search and research agents learn to browse, read, and synthesize. Code agents write, run, and fix programs over many trials. Math agents reason formally and check themselves. GUI agents click through apps' websites to complete tasks. Vision embodied agents perceive and act in the physical or simulated world. Multi-agent settings coordinate teams of AI workers. Thank you for tuning in. Let us know in the comments if there's a paper or topic you'd like us to explore.